Today we will continue our study of polygons, but we'll also add special consideration to the angles in the interior of polygons, as well as characteristics of special quadrilaterals. As previously discussed, polygons are made up of a number of sides and also a number of angles. So for a polygon that has 3 sides, of course that is a triangle. Quadrilaterals come in a variety of forms. All quadrilaterals will have 4 sides and 4 angles. A pentagon is a shape with 5 sides and 5 angles. A hexagon has 6 sides and 6 angles. A heptagon is a figure with 7 sides and 7 angles. An octagon has 8 sides and 8 angles. A nonagon is a shape with 9 sides, and of course it has 9 angles. And a decagon is a shape with 10 sides and 10 angles. We understand this concept, and again, this is for our review purposes. Angles also play an important role with polygons, and I think this is where our polygons become more interesting. When you look at the figure in the upper left box, you can see that this is called a 90-degree angle. It's also called a right angle. At this time, you should stand up. Yes, stand up in front of your computer. I'd like you to turn your body so your right shoulder is near your computer. Now, turn your entire body so that you're once again facing your computer. You've just completed a 90-degree turn. Continue turning, and now your left shoulder is closest to the computer. You've completed another 90-degree turn. In total, you completed a 90-degree turn plus a 90-degree turn, so you have completed a 180-degree turn. Now have a seat again and look at the box in the upper right. As you can see, that is a 180-degree angle. It's a straight line. So if you are facing one direction and you turn clear around and face the opposite direction, you have completed a 180-degree turn. This angle is also known as a straight angle. Next, we'll look down at the left-hand box, and you can see that that is an acute angle. An acute angle is anything less than 90 degrees. You can also see that this angle is noted by the curved line between the 2 line segments. So when you see the line segments form a vertex, inside that angle will be a curved line to show that it is an angle. The final angle that we'll study today is in the lower right-hand box. It's called an obtuse angle. It's an angle that is greater than 90 degrees. So if you have 2 line segments and it forms together at a vertex that the angle is 91 degrees, that is an obtuse angle. Obtuse angles are anything that is more than 90 degrees but less than 180 degrees. So there's a very wide range of obtuse angles, which is similar to acute angles. An acute angle is anything less than 90 degrees, but greater than 0 degrees. Let's review the vocabulary that we've worked on today with this fun shape. As you can see, there are 5 sides. So this is a pentagon. This plane figure is a pentagon because it has 5 sides. In our reminder box, we note that a right angle is exactly 90 degrees. When you look at this figure, all of the degrees for the various angles have been written for you. You can see there are no right angles in this polygon. There's one that's very close, and it's labeled vertex A. But it is less than 90 degrees, so it is an acute angle. Letter B, in the very top left, you can see that angle is 52.3 degrees. So what kind of angle would that be? Yes, it would be an acute angle. Continuing to the right, we see this concave portion of the pentagon. And point C, the angle in that section is greater than 90 degrees. So it is an obtuse angle. Let's continue to the right, and we see letter D at the vertex of those 2 line segments. Again, it's less than 90 degrees, so it is an acute angle. And moving down to the final angle of this polygon, we see the letter E at the vertex of those 2 line segments. You can see that the degrees are listed as 125.3 degrees. This angle is an obtuse angle because the degree measurement is greater than 90 degrees. Now we're going to turn our focus back to polygons, but polygons in the quadrilateral family. As you know, quadrilaterals have 4 sides. There are a wide variety of quadrilaterals, but today we're going to consider the trapezoid, parallelogram, rectangle, rhombus, and square. We'll try to determine the characteristics that are required to make each of those quadrilaterals the special figure that they have become. First, let's talk about the trapezoid. For our purposes, this quadrilateral has exactly 1 pair of parallel lines. As you can see on the top trapezoid, the parallel lines are towards the top of the page and the bottom of the page. The lines on the sides are not parallel. They would eventually, if they extended, would go forward and intersect or cross over one another. But the lines at the top and the bottom of this trapezoid will never meet. They would go to infinity and beyond and never touch. The same is true on the bottom trapezoid of the lines that are on the left and the right of this figure. Those 2 lines are parallel. If they extended into space, infinity and beyond, they would never cross. The same is not true for the top and bottom lines on this trapezoid. So again, when we are discussing trapezoids, our working definition will be a figure with exactly 1 pair of parallel lines. Another familiar quadrilateral is the parallelogram. Again, the figure has 4 sides. What makes this plane figure unique is that it has 2 pairs of parallel lines. The sides that are opposite are parallel. So in the top figure, you can see the top and bottom line are parallel. they would never meet. The same is true of the left side and the right side. Those lines are parallel. They will never meet. What makes a parallelogram so special is that the angles that are opposite one another are the same size. They will have the same degrees. And if you note the bottom parallelogram figure, the angles in red will have the same number of degrees, and the angles in yellow will have the same number of degrees. The red angles are opposite each other. The yellow angles are also opposite each other. And those two angles will always be consistent and have the same number of degrees. You have been learning about rectangles since you were in preschool and kindergarten. But a lot of people never really think how special a rectangle is. As you can see, a rectangle has two pairs of parallel lines. So that's similar to a parallelogram. But a rectangle goes one step farther. What's extremely interesting about a rectangle is that it has 4 right angles. Look at the bottom figure. You can see by those straight, squared lines in each corner that notes that they are 90-degree angles. So a rectangle must have 4 90-degree angles. If any two of those angles are less or greater than 90 degrees, it's no longer a rectangle. A rectangle must have exactly 4 right angles. The parallel sides can be of differing lengths, but each of the parallel sets must be the same. So we can see in these two examples, there are 2 long sides, which are parallel to one another, and 2 shorter sets of lines that are opposite each other. And now we'll move on to a rhombus. In street language, a rhombus, many people call a diamond. But as mathematicians, we're going to use the mathematical term, which is a rhombus. A rhombus, of course, has 4 sides. But what makes it so special is that all those sides are of equal length. A rhombus can have varying angle degrees, but it must have 4 sides of equal length. If you look at the bottom rhombus, you can see that the opposite angles have exactly the same measurement of degrees. So the 2 yellow curved lines of the angles that are opposite one another show that this is exactly the same angle size. It is similar to the red curved lines. The red curved lines show that those opposite angles are exactly the same measurement. So the most important things that you must remember about a rhombus is that the sides must be of equal length and opposite angles will have a measurement of degrees that is the same. Our final quadrilateral in today's study is the square. Now, a square, which is a very typical shape, and you've been talking about it for years, has a lot of requirements that are necessary for a square to have its title. Of course, it has 4 sides, but all those sides must be of equal length. There is absolutely no way that a square can have sides that are of different lengths. So that's the first requirement. The second requirement is that a square must have 4 90-degree angles. So that makes squares a very specific shape. 4 sides of equal length, 4 right angles, 1 in each corner. If you satisfy all of those requirements, you have a square. A square is a very special parallelogram because it has 4 90-degree angles similar to a rectangle, but it also has 4 equal sides, which is similar to a rhombus. A square is probably the most unique quadrilateral that we've studied today. To summarize our study for today, we have found that polygons are determined by the number of sides that they have in their figure. This will also determine the number of vertices and the number of angles that are in the interior of the polygon. Angles play an important role when we define various polygons. The family of quadrilaterals will be even more specific with the type of angles that are inside the quadrilateral, and also whether or not the lines are parallel with one another. When you're trying to name a quadrilateral, look very carefully at the sides of the figure, whether or not they're parallel. Also, look closely at the angles in the interior of the polygon. Once you determine the lines and the angles, you will be able to name that quadrilateral.